well, maybe on some of the questions you've already worked for. So even some of the questions in from chapter 1 to chapter 2, I think what we talk about today will be useful. So anyway, I'm just blathering. All right, so let's jump in here to chapter number 2 and talk about measuring GDP. So if you remember where we left off yesterday in chapter 2, we were talking about measuring GDP, and we talked about the difference between real and nominal GDP, right? And if you remember, nominal GDP means we use current prices, right? In fact, I don't know that I actually defined nominal, what the word nominal means yesterday, but let me do that now. Nominal means measured in current prices, okay? Or another way you could think of nominal is not adjusted for inflation. Real means adjusted for prices, for differences in prices, or adjusted for differences in inflation. And real can also mean measured in current prices. So if you remember what we did yesterday, we first calculated nominal GDP, in which we used current prices to measure GDP. And then we calculated real GDP, in which we used a base year to use a constant set of prices to measure GDP, right? And so we talked about why real GDP is a better measure of well-being, because it doesn't let inflation distort what's going on, right? What you're really getting is productive changes in purchasing power, and you're not getting just, changes in the price level that are distorting what's going on. Now, one of the things we didn't talk about yesterday is that you can actually use nominal GDP, use that data to measure inflation, right? So not only is this a measure of real and nominal GDP, but it's also a measure of inflation. So I'm going to share with you here my iPad here, right? Let's see if this is working here. Okay, so measuring inflation. I always use, in this book, we'll use pi to denote inflation. So measuring inflation. As we talked about yesterday, we figure out how to calculate nominal GDP and real GDP, right? So there's actually a measure of inflation, and this is what we'll call the aggregate price index. And the aggregate price index is really a pretty simple measure of inflation, right? First step is you calculate the aggregate price index. And all the aggregate price index is, it's the ratio of nominal GDP to real GDP, and you multiply it by 100. So for instance, if we're calculating the aggregate price index in 2019, we take nominal GDP in 2019, we divide by real GDP in 2019, and then we multiply by 100. So this is an index, right? An index is, another word for index could be a ratio, right? It's just the ratio of nominal GDP to real GDP. However, this in of itself doesn't tell us what inflation is, because inflation is a percent change in the price level, right? That's how we talk about inflation, as a percent change. So the second step is we have to calculate the percent change in the API. And how do we do that? We just take the new API divided by the old API divided by the old API. Ran out of room there, but you multiply it by 100. So when we calculate nominal and real GDP, we can also use this data to calculate a measure of inflation, right? By simply taking the ratio of nominal GDP to real GDP and then seeing how this ratio changes over time. So let's do an example of this using the data that we used yesterday. So if you remember, we began by using 2019 as a base year. And if I can remember what we found yesterday, sorry, we found that nominal GDP in 2019 was 2,300, right? No, I'm sorry. I think I have this wrong. I can't read my own writing. Hold on one second. I got this right. Yeah, 1,700. Okay, so we calculated nominal GDP in 2020 as, I'm sorry, nominal GDP in 2019 is 1,700. Nominal net GDP in 2020 is 2,300. And then we calculated real GDP in 2019 as 1,700, because remember in the base year, nominal and real GDP are always the same. And then we calculated real GDP in 2020 as 1,400. Okay, so that's what we did yesterday. Sorry about that. So now how do we calculate inflation? Step one, we calculate the aggregate price index for each year. Remember what the aggregate price index is. It's nominal GDP divided by real GDP times 100. So what was nominal GDP? Well, in the base year, this is pretty easy because it's nominal and real are the same thing, right? In the base year, the aggregate price index is always equal to 100. What's different in 2020? Well, in 2020, we knew that nominal GDP is 2,300, real GDP is 1,400. Okay, somehow I didn't write this down. Get out our calculator. 2,300 divided by 1,400 is 164.3. Okay, that's our aggregate price index in 2019 and 2020. And then the second step is we calculate the inflation rate, which is the percent change in this. So we take the new observation minus the old divided by the old. And what do we get? 64.3%. That is the measure of inflation.
Do you want us only rounding up to the first decimal point, or does it depend on the situation?
I mean, I'm not super picky, to be honest with you. Don't round too much, right? You should probably go to at least to a 10th, but I'm more interested that you do it right. And if you round a little bit too much, I'm not gonna go nuts. Okay, so when we measure GDP, we are also creating a measure of inflation, right? Because really, quantity and price cannot be separated in GDP, right? As we've talked about, to calculate GDP, you have to measure both changes in quantity and changes in the price, right? You have to measure changes in real GDP and measures of inflation. Now, if you remember yesterday, we left off by saying this is not quite right though, because this answer is sensitive to which base year you pick. Will you get the same answer if you pick 2020 as the base year? And the answer is no, right? The answer is no. If you pick 2020, you'll actually get a slightly different answer, right? So if you pick 2020 as the base year without going through all of the math, if you go back through and work this all out using 2020 as the base year, what you'll find is that you're going to find inflation is 64.7%. It's going to be slightly different. And once again, why is that? It's different because as prices change, they weigh different goods more heavily or less heavily. And so you're going to get a different answer based on what you use as the base year, right? So what's the best answer here? Well, how do you deal with this problem? You should chain weight. Right? And chain weighted inflation just means, you average these things together. For some reason my 6s look like G's today. And so the best answer here is, can't do any math. No, that's right, 64.5%. That is really the best answer. So once again, when you chain weight, you have to do everything twice. You have to do basically the first year as the base year, calculate. You use the second year as the base year, calculate, and then you average that out, right? So just like you do that for real GDP, percent change of real GDP, you really have to do that for inflation. And so for the question number, I can't remember what number it is on your homework, but it asks you to calculate what the inflation rate is using this method, and it asks you for chain weighted inflation. So what that means is you're going to have to go through and calculate, for every year, you're going to have to calculate 2 sets of inflation rates and then average them together. Okay, does that make sense? So yeah, it's a lot of fun, right? It's a lot of fun. You'll really enjoy that. All right, so that really kind of gets us through some of the technical stuff related to calculating GDP. I thought I'd move down onto now to talk a little bit about, does GDP measure well-being? So we're going to talk a lot about GDP. We talked a lot about GDP in principles, right? And so a legitimate question here that many people have is, you know, why do we spend so much time talking about GDP? Right? Does it really measure how well a country is doing? Or does GDP essentially create this impression that a country is doing well when in fact it may not be doing well? Just to give you a little bit of background into GDP so you know the history of it, GDP was basically developed during World War II as a war planning method, right? So in order to plan for the war, a big part of winning World War II is essentially making more than other countries could. And so we needed to know what we were making, right? Where are we devoting our resources? And so GDP is very much kind of conceptualized around this idea that you have to build to plan for war. And so in GDP, there is a focus on spending, right? It's what you make and what you spend gets counted in GDP. And so critics have talked about all sorts of problems that are created by the fact that GDP really has a pretty narrow definition of what doing well means, right? According to GDP, you do well if you spend more and you make more stuff. And so many economists have talked about, not just economists, but people outside of the economics profession, talk about the things that GDP misses. One of the things that GDP misses, I'll share with you some notes here. One of the things that GDP misses is that it does not include externalities, right? So hopefully remember from principles, what's an externality? An externality is that when some market transaction imposes a cost or a benefit on someone other than the buyer and seller, right? An externality is when a market transaction imposes a cost or a benefit on someone other than the buyer or seller. So in everyday life, there are millions of externalities that are created that GDP simply ignores, right? For instance, I have some negative externalities here, such as crime or pollution or congestion, right? Pollution is a classic example of an externality, a negative externality, in that, if you build a hog farm and your hogs shit in the river and the shit goes downstream, what do you care, right? It doesn't impact you, right? It doesn't impact the person who buys the meat from your hogs, so you're clear. But of course, that imposes a lot of costs on society that are not incorporated between just the buyer and the seller of that hog, right? And so, right, by ignoring things like pollution or maybe crime or congestion, right, it really ignores a lot of important things about well-being, right? I mean, for instance, you could think about what's going on here with this pandemic is creating all sorts of negative externalities, right? Every time that I go to the grocery store, I'm potentially infecting other people, right? Am I thinking about my potential of infecting other people when I make a cost-benefit decision to go to the grocery store? Maybe not, right? And as a result, I'm creating a lot of negative externalities. These things just don't get included in GDP. What gets included in GDP? Well, the stuff that I buy at the grocery store, right? But it's not incorporating the potential for infecting other people or for other people getting sick or dying or any of these other things, right? And so this is why what often happens is that GDP goes up, but people feel worse about it, right? For those of you who've traveled abroad, you've gone to less developed countries where pollution, particularly things like air pollution, can be intense, right? And so while people in some sense are better off, they might have more food to eat or bigger houses, in other senses they could feel worse off, right? Because the quality of their life in terms of their water or their air or crime or just simple congestion can actually make you feel worse about your life. And so that's why for many people, when GDP goes up, they might actually feel worse about their situation. GDP, another problem with just regular GDP, problem number 2 here, is that it doesn't include population, right? And so this is one of the reasons why per capita GDP is probably a better measure of well-being, right? And particularly when we compare GDP across countries, we usually want to look at per capita GDP, right? Per capita GDP. Because it's going to be very difficult to compare GDP in the US to China, given that China has about 4 times the population of the US. Many people have criticized GDP on this third point, that GDP doesn't include household production. There's a lot of things that are not included in GDP because they're not included in markets. So, for instance, many feminists have critiqued GDP because it doesn't include women's work, right? Women's work meaning work that's traditionally done by women, such as raising children or making food or in less developed countries, maybe having small gardens or watching other people's kids or all these kind of things. One of the reasons why GDP has risen since World War II is because so many more women, their work is now counted in GDP because many women have left the household and are working in markets. And so when you leave the household and you work in a market, your work gets included. So, think about a woman in the 1940s who stayed at home to raise her kids. Her work largely was not included in GDP. Now, if that same woman goes out and gets a job, not only is the value of her work in her job included in GDP, but also if she pays somebody else for daycare, that work is now included in GDP. And so, many economists say, that kind of distinction that some work is included and not other work really makes GDP, not a great measure of well-being. And they have a point. That's a legitimate point, particularly in less developed countries, where more people work in informal markets, right? Meaning more people work at home, or they kind of do work for people, on side gigs. Whenever the gig economy is bigger, GDP is probably going to be a worse measure of GDP, of well-being, sorry. So in the US, the informal economy is probably only about 10% of everything that's going on. But in less developed countries, it can be upwards of half of what's going on. And so obviously GDP is going to miss a lot. Also, a lot of what's going on in countries is the underground economy. And here we mean the economy associated with illegal transactions. You notice here that in the US, it's been estimated that, probably illegal activity is about 5 to 6% of GDP. But in a country like Italy, it can be upwards of 35% or even more of GDP is in the underground economy. And so, right, GDP is going to be a worse measure of well-being in countries where a lot of activity is going on under the table, right? Sometimes this is illegal activity. Sometimes it's just activity to avoid paying taxes, right? So some countries like for instance, Greece, have a terrible problem of an underground economy, not because there's a lot of illegal activity per se, but because a lot of people, once again, do things under the table because they don't want to pay taxes on it. GDP ignores resource depletion. So if a bunch of trees are just sitting around in a wood, what are they contributing to GDP? Almost nothing. Well, not almost nothing. They are contributing nothing. What happens if you go and you cut down those trees? Now you're contributing to GDP, right? And so many people have criticized GDP that it really encourages short-term thinking, right? Instead of encouraging investments for the future, it really encourages you to spend now, right? And as it also doesn't include what we talked about earlier, the market prices of pollution, right? Global warming, changes in climate, right? None of this is really showing up directly in GDP because once again, it's not directly related to spending. And then finally, a legitimate criticism of GDP is that GDP, even per capita GDP, is just an average, right? You're just taking a big number and dividing it by the population and telling you what the average amount is that a person gets. But we know that very few people in the United States are average, right? We have a relatively small and shrinking middle class. And so when you have fewer people that are average, you have some people that are very rich and a lot of people who are very poor, right? We talked about this yesterday, that in the US, the top 1%, this is people who make more than $230,000 a year, earn half of all income, right? So the top 1% is earning half of all income in the United States. So per capita GDP is not really a great measure of how the average person is doing. Because as I said, there's very few people that are average in the United States. You have some people who are doing very well and a lot of people who are not doing so well. And the people in the middle, there's not a great deal of them. And unfortunately, that number is shrinking over time, as we'll talk about. One final problem with GDP is that, it ignores leisure, right? You only can create or contribute to GDP when you're working and making things. If you take a day off and watch Netflix, that might be good for you on an emotional and psychological basis, but that is not contributing to GDP. And this is actually one of the reasons why the US has higher GDP than Europe. Europe consumes a lot more leisure than we do, right? So in other words, Europeans tend to work less and accept lower incomes. Americans tend to work more and spend more money, right? So where Americans tend to consume, Europeans tend to just enjoy leisure. And that's not necessarily a bad decision, right? But because of the way we calculate GDP, it makes the US look more prosperous than maybe we are. So you might say, after talking about all these things, God, there's so many problems with GDP. Why in the world do we use it? Well, the simple fact of the matter is there's no perfect measure of well-being, right? There's no perfect measure of how well a country is doing. Every single statistic that tries to measure how well a country is doing is going to have biases, and it's going to have blind spots, and it's going to miss things. One thing, though, that we can take comfort from GDP is that it is highly correlated with other measures of well-being. So whether if you use well-being as health or life expectancy or infant mortality or education rates, GDP is highly correlated with all of those things, right? And so here's a table from your book that actually looks at per capita GDP in the United States. This is relative to the United States, right? So in other words, the US has 100, Sweden has about 79% of GDP. And then in these other measures, you can see what the US looks like relative to life expectancy, consumption rates, leisure rates, and here's a measure of inequality. And without kind of going through the details of this, I'll just tell you that all of these things are pretty highly correlated, right? That countries that have high GDP also tend to have high life expectancy. They do tend to consume more leisure, so that relationship is not perfect. And inequality is a little bit more complicated. What your authors did here is they actually said, let's, instead of looking at per capita GDP, let's calculate a measure called welfare. And welfare is going to be a weighted average of how long your life expectancy is, what your consumption is, what your leisure is, and what income inequality is within your country. So they basically weigh these four factors that come up with a measure called welfare. And if you note here, welfare is closely correlated with per capita GDP, right? So if you look down across these countries, yes, there are differences here and there. For instance, Norway is a country where its welfare is considerably less than its GDP. South Africa is a country where welfare is considerably less than its GDP. But for the most part, there's a lot of correlation here between other measures of how well you're doing and what GDP is. And so what does that mean? It really means that we're going to use GDP, right? We're going to use GDP, not because it's perfect, but because it's probably the best we have. And we have some confidence that it's pretty well correlated with other measures of how we're doing, okay? But as economists, right, it is crucial that we critically think about the data that we use, right? Critically important that we think about the data that we use. So, we have to be cognizant of the weaknesses of GDP and not try to overclaim, right? Not try to overclaim that if a country sees their GDP go up by 2%, that somehow we're 2% better off, right? I mean, this isn't much different than politicians who, when the stock market goes up, say, hey, re-elect me, the stock market is going up, right? Well, sure, the stock market going up is a good thing, But that's not the only thing that matters, right? And so while GDP is a much broader measure of welfare than the stock market, we shouldn't kid ourselves that GDP is the only thing that matters, right? We should be paying attention to this. There's another issue here that I want to talk about, and then we're going to take a little break. And that is, how exactly do we compare GDP across countries? Because there's some pretty significant problems looking at GDP across countries. Shoot. Hold on one second. Sorry, my iPad is working kind of funky here. Here we go. What? Talk amongst yourselves. Okay, something funky is happening with my iPad. Well, damn it. I tell you what, let's take a 5-minute break. All right, this is a good time. Let's take a break. Let me see if I can figure out what's going on with my iPad, and then we'll come back and we'll finish up chapter 2 here. So let's see, what time is it? How about 9:45? We'll take a little bit longer break. 9:45, we'll come back. Once again, I'm going to leave the Zoom going so that if any of you want to chit chat or talk, or this might be a good time if some of you want to get together on Zoom and work through your homework so you can kind of talk to each other. So I'll just mute the video and you can talk amongst yourself. So meet you back here at 9:45. All right, hey everyone. I think maybe I got my iPad working again. While I'm thinking about it, I'll try to remember to announce this again at the end of class, but I have a faculty meeting today, and so we will not start this afternoon's class till 1 o'clock, okay? So I forgot to write that in the email that I sent you yesterday, but afternoon class will not start till 1 o'clock, so we'll just go from 1 to 2, right? So don't show up at 12:30, you get an extra half hour to lounge and do all the wonderful things that you can do during this COVID era, such as maybe squeeze in another episode of The Office. So, Brian, I'm looking at you. So, I mean, it actually is my dream to like work with Stanley. Stanley, everyone's got like an office character that speaks to them. Stanley is the one that definitely speaks to me. So I appreciate your background there, Ryan. So anyway, 1 o'clock. Yeah, have a little bit extra time over lunch. Okay, so picking up where we left off, I was going to try to talk about comparing GDP across countries. Oh, you got to be kidding me. This is really amazing. Sorry, hold on one moment. Let me see if I can figure out. When this works. Okay, maybe it's working now. God, this thing is so sensitive. All right, let's try this one more time. So, comparing GDP across countries. So if we look at 2017, we see that US GDP was about $17.7 trillion, okay? China's GDP was about 75.2 trillion RMB. So how are we actually going to be able to compare standards of living across these two countries? What do we have to do? Well, there's really three things that we have to do, right? And so whenever you compare GDP across countries, you have to think about three adjustments that need to be made if we're going to make any sort of accurate comparison. The first is obviously that we need to adjust for the exchange rate. Right? Obviously, we need to adjust for the exchange rate. In 2017, we find that $1 was about 6.14 RMB. And so what we need to do, first off, is we need to divide right, I forgot the trillion in there, 75.2 trillion RMB divided by 6.14. And what do we get? We get about 12 point, well, geez, I'm screwing this up here. Should not be RMB, that should be dollars, right? $12.24 trillion. So now we have a little bit closer comparison, right? We see that US GDP was 17.7 trillion. Chinese GDP was about 12.24 trillion. But there's really another adjustment that we need to make here, and that is for differences in the price level. The price levels between the two countries are not the same. And what do I mean by this? $1 in China will buy you more than $1 in the United States. Okay? $1 in China will buy you more than $1 in the United States. So if I have $12 trillion of purchasing power in China, I'm really going to have a higher standard of living in China than I do in the United States. How much higher? Well, economists have estimated that if you look at the US price level, Chinese prices are about 59% of US prices. You're right, they're about 59% of US prices. So if something in the US costs $1, in China it costs about 59 cents. Now, obviously, for those of you who've been to China or are living in China, you'll know that this varies widely across goods, right? So there's no way that housing in urban areas of China is 59% of what it is in the US. In fact, in urban areas of China, housing is much more than it is in the United States. So there are some things that are way more expensive in China. There are things that are way cheaper in China, right? So this is an aggregate measure, right? An aggregate measure that has, quite honestly, a lot of ambiguity to it. But what we need to do with this number is we think about, well, then how much does that 12.24 trillion buy? If we divide it by 0.59, we're getting really an estimate of the purchasing power of that 12.24 trillion. So divide 12.24 divided by 0.559, and we get $20.74 trillion. So now if we compare to the US, actually, in some ways, the Chinese economy is bigger than the US economy if we account for purchasing power. However, there's a third adjustment that we need to make to this number, and this is an obvious one. Population, right? It's one thing to say the size of the Chinese economy is bigger, but of course, China has about 4 times as many people as the United States does. And so we really need to think about per capita GDP in both of these countries. So per capita GDP in the US is 17.74 trillion divided by 325 million. Right? Or actually, I'm just going to do it like this. I'm obviously dropping a lot of zeros here. Sorry for doing this. I should have the zeros out right, but it's kind of hard to fit it all on this thing. But if you divide $17.74 trillion divided by 325 million, you get about $54,000 a person. What about for China? We just calculated that China has 20.74. But they have about 1.386 billion people. So their per capita GDP is about 14,963. So what can we say in the end? That the US has about 3 times the per capita GDP of China. But it takes quite a bit of work to get to that number, right? It takes quite a bit of work to get to that number. This is how you can get, this is a classic example of how you can lie with statistics, right? Classic example of how you can lie with statistics. If your intent is to prove that the US economy is much bigger than China, then what do? You forget step number 2 here. You forget the fact that purchasing power is different between the two countries. Because that's one of the things that makes China look much richer. So if your intention is to prove that China is a lot poorer than the United States, right? You forget that. If your intention is to prove that China is a lot richer than the US, you forget about the fact that you have to think about differences in population, right? So even calculating something as seemingly simple as GDP across different countries, there are different answers, right? There are different answers. Another way that you can get different answers is depending upon what exchange rate that you pick. Between the US and China, the exchange rate is relatively stable. But between the US and other countries, sometimes there can be big fluctuations in exchange rates, sometimes by 10 to 20%. And so if you pick an exchange rate on a certain day, you can make GDP look much higher or much lower, right? So for instance, if we were trying to compare GDP in the US versus the Euro area, if you pick a day when the Euro appreciates by 10%, it's going to make Europe look 10% richer. Or if you pick a day in which the Euro declines by 10%, it's going to make the Euro look 10% poorer. So, as Mark Twain said, there's lies, damned lies in statistics, right? And so the point here, obviously, is not to try to tell you how you lie with statistics, but for how you become a more insightful consumer of statistics, right? When you see comparisons between US and Chinese GDP, you should be asking yourself, how did they get that number? Did they think through everything? What exchange rate are they using? How are they accounting for purchasing power parity, right? The fact that there's differences in price levels between the countries. How are they looking at per capita GDP, right? Those are really important questions that you have to be asking yourself as kind of a critical consumer of information, okay? And so, these are the things that we do, right? Hopefully as good economists, right? As we want to compare GDP across countries, making sure that we're using purchasing power parity exchange rates, right? And what that means is that you're using exchange rates that are adjusted for differences in purchasing power. And then we also want to make sure that we're looking at per capita income, right? Because per capita is going to adjust for differences in population and give us a little bit better, not perfect, but give us a little bit better idea about what's going on. Okay, so that is really chapter 2. Does anybody have any questions about chapter 2, calculating GDP? So if not, we're going to move on to chapter 3 here and begin to talk more about economic growth. And chapter 3 is really another data question. Is everybody there? Shit. How's it doing now? Hmm. Maybe it's working a little bit better now. Is that thumbs up from people? Kind of. Still, it's still looking a little glitchy to me, but if I start to break up again, text me. Yeah, I think we now know, at least on my end, what the limit of our Wi-Fi. So my partner got on a meeting at 5 o'clock, and as soon as she got on, I think my Wi-Fi started to really slow down. So, okay, so chapter 3. Okay. A little bit about how to handle it. We want to talk about some data visualization techniques to help us visualize what's going on, and the ramifications of growth over time. So as we talked about yesterday, economic growth is one of the predominant factors in economic history. If we go back to 1900, the life expectancy in the US was 47 years. Today it's 78 years, right? So we've increased life expectancy by about 30 years. $5,000 a year. Today, as we just calculated, it's more than 50,000. In fact, today it's closer to 60,000. Infant mortality in 1900 was 14%, right? Today it's less than 1%. Only 10% of Americans had high school education in 1900, right? 90% of Americans had no car and no electricity, right? So all of these things are significant improvements in our standards of living. It's actually a legitimate question. Would you rather be a college student today in 2020, or Nelson Rockefeller, the richest man? I mean, yes, it was very nice to be the richest man in the world in 1900, but you also didn't have cell phones, you didn't have internet, you didn't have your life expectancy was still smaller in 1900 as the richest person in the world than it is today. So, the fact that there's actually some ambiguity here about whether it would be better to be the richest man in the world in 1900 or you today is just a good indicator of how much things have improved for most of us. Having said all of that, that doesn't mean that things are perfect, right? Economic growth does have negative consequences. Two of them that are pretty obvious is, one, the environmental consequences, right? Everything that's going on with global warming is a direct consequence of economic development. Economic inequality is a direct consequence of economic development, right? When everybody was poor, there was no inequality, right? So in a world where everybody was pretty much living at subsistence, you also had pretty small levels of inequality. With economic growth does come economic inequality, and particularly what we've seen here in the last 50 to 60 years in the United States is that as growth has gone up, we've seen increasing inequality. And so these are all things that we need to kind of talk about, right, and make sure that we understand. And so I want to begin this chapter by talking about some of the big facts about growth, right? This won't be a technical discussion, but kind of a more big picture where we look at the data, right? And so, what we're doing here is we are applying that macroeconomic approach. The first step in the macroeconomic approach is to collect data to help us describe the problem, right? And so that's really what we're doing here in chapter 3. And then what we're going to do for the rest of the week in chapters 4, 5, and 6 is then we're going to develop a model to try to explain these facts, right? And make sure and see if we can develop a model that help us explain the facts that we know. But in this chapter, we want to make sure that we understand the facts, okay? So let's talk about the big facts of economic growth. Hold on one second. Sorry, I'm having all sorts of computer issues now. Okay, this lecture may not be going to the Economics Hall of Fame. Gosh. So sorry, what I'm struggling with is I have all the notes I want to show you in a Word document, and for some reason, my Word is not working, and I have no idea what the problem is. All right. Well, anybody want to tell me about how their Thanksgiving was?
I actually had a question, Todd.
Yeah, sure.
So, for our equation that we're using to measure inflation, if
Hmm.
it makes the assumption that prices only adjust due to inflation, are we just fine accepting that assumption for this class?
Yes. So remember, when you're doing this in the real world, you're not just talking about one or two goods. In our examples, we have like two goods, right? But in the real world, you're talking about hundreds of thousands of goods, right? And so the change in one or two goods is going to have a minimal impact on inflation, right? So when you're only going to get significant changes in inflation when it's a huge percentage of the goods that are changing in price. So your question is a good one, Ben, because technically when we talk about inflation, we're talking about change in the economy-wide price level, right? So a change in the price of, oranges because of a freeze in Florida is not really inflation. But as a practical matter, if the price of oranges go up in Florida, it's not really going to impact inflation, right? Because it's too small a percentage of the big picture.
Okay, okay.
So, so right, the key is to make sure you get enough goods in there. And if you get enough goods in there, then the hope is that in general, what you are capturing is the economy-wide price level. Okay, maybe this is working now. All right, here we go. Maybe. The spinning wheel of death. This is just amazing. And nothing seems to be working very well here. So are you guys seeing anything in your screen sharing? Are you seeing this chapter 3? Okay, good, because it looks weird to me. So let's talk about the big facts of economic growth. The first one, economic growth is a relatively recent phenomenon, right? So really for most of US history, what we've seen is very little increase in economic growth. And how do we know that? Well, we know that for a couple of reasons. For most of US history, we haven't seen any increase in population growth. And I'm sorry, not just US history, world history. So most of world history, population growth has been extremely low. And given that most people were working at or living at subsistence levels of income, the only way you could have more people is if you had more economic output, more growth. And so the fact that we weren't really generating more people suggests that growth was very, very low. This didn't really change until the Industrial Revolution, as you can see here in figure 3.1. The Industrial Revolution began in different times in different areas of the world. But you can see in the US and in Europe, it began in the mid 1700s roughly. And that's when we saw this dramatic increase in standards of living, right? Up to that point, really standards of living and population growth were pretty slow. So only in the mid 1700s did we begin to see increases in standards of living. And as standards of living went up, we also began to see increases in population growth, right? One of the things that we see from this graph, though, is that this refutes the idea that somehow rich countries got rich by exploiting poor countries, right? This is often known as the dependency theory of growth. And the problem is the dependency theory of growth just is not supported by the data. It's not like poor countries have gotten poorer at the same time rich countries have gotten richer. What's happened is that rich countries have gotten richer and poor countries just haven't developed, okay? So, or developed very little. So, while poor countries have gotten richer, the rate of growth is significantly less than what we've seen in rich countries. To show this to you another way, I'm going to show you. Gosh, this is so weird. show you something else if it shows up here. There we go. Right. So this is looking at per capita GDP in what today is the developed world and in what is today the underdeveloped world or less developed world. So if you go back to the year 1000, what you see is that there's very little difference between per capita GDP in the less developed world and in the developed world. In fact, if you go back to the year 1000, what was the richest area of the world? The Middle East and China. If we move forward to the year 1500, we begin to see, yes, the developed countries begin to pull ahead a little bit, but there's still not really much difference. It's only when we begin to get to the Industrial Revolution, and that's when countries that are developed today got significantly richer. Countries that are less developed, they got richer too, but by a much smaller proportion, right? And so where does all this income inequality come from? Well, it comes, once again, not from poor countries getting poorer, because poor countries have gotten richer. They just haven't gotten richer as fast as other countries, right? And so this leads us then to our third fact of economic growth, which is that what we see when we look across the world is that some countries are growing and others are not. And this is true whether you're rich, but it's particularly true when you're poor. We do see some countries that are growing. And in fact, some countries are converging, right? Converging, when we use the word convergence, we're talking about basically poor countries growing faster than rich countries so that their income levels are getting closer together over time. We do see convergence. As you've seen in other graphs, and as we'll show you here in a minute, China is converging with the developed world, right? China is poorer than the developed world, but they are growing faster than the developed world, and they've been growing faster now for 40 years. And so what that means is that they're converging. But other countries are diverging. And what this means is that they're poor and they're growing slower than the rich world, right? So for instance, in much of sub-Saharan Africa, not only are standards of living much lower than in the rich world, but they're not growing as fast as the rich world either. So the differences in income are actually getting bigger over time, right? So this is one of the weird things that we see, is that there is both divergence and convergence at the same time, right? Both convergence and divergence at the same time. To show you some pictures of this to kind of illustrate this. This is what's called the global elephant curve, right? The global elephant curve. And why an elephant curve? Well, I guess if you squint your eyes or you're inebriated, this looks like an elephant to you. But you can see the elephant's back and then its trunk, right? And so what is this curve trying to capture? The vertical axis is how much real income has gone up between 1980 and 2016. So in other words, basically over the last 40 years or so, how much has income gone up? The horizontal axis asks, how rich were you today, right? So in other words, what income percentage do you fall into? Are you among the global 10%, the global 20%, the global 50%? Are you up here? And you notice this stretches out as you get to the top 10%, the top 1%, the top 0.01%, right? So these are the people that are at the very tip-top rich, and these are the people that are at the tip-top poor of the global income distribution. Forgetting about countries, just looking at where you are globally. Okay, so what does this graph tell us? Well, this graph really tells us something very interesting. It tells us that what kind of people have seen the biggest increases in income here over the last 40 years? It's people at the very bottom of the income distribution and people at the very top. They are the people who have seen the biggest increases in their income. Who are these people at the very bottom? Well, these are people that were living near extreme poverty, right? Largely, these are people who have lived in China and India, right? If we actually want to put a place to them, most of these people are Chinese and Indian. This has been a good 40 years for them, right? They've actually had high standards of living, or high increases in standards of living. Who else has boomed? Well, the global 1%, right? And the global 1% is really, in the United States, our top 10%. The top 10% of the income distribution in the US has done very well. And this is the same across most developed countries. Who hasn't done so well? Well, this is the global middle class, the people who live in 70 to 80 to 90%. And who are those? Most Americans, right? Most Americans live somewhere between the global 60% and global 90%. And this has not been a particularly great period of time of economic growth for most Americans. And so this graph right here, in many ways, tells you a lot about our dysfunctional politics, right? And it tells you a ton about why globalization is so controversial. Because the last 40 years, which is really the era of globalization, has been great for many people. It has been great for the global poor. It's been great for the global rich. It has not been nearly as good for the global middle class. And a lot of those global middle class or global upper middle class are Americans, right? So yeah, right, this graph really tells you a lot about what's going on, right, in our politics. Here's another way of kind of looking at this. This is looking at the global income distribution. And so what this is taking everybody in the world and just plotting them on what their income is, okay? So I apologize, this is a little hard to read, but I think we can kind of get the gist of what's going on here. If we look back in 1800, what did we see? Most of the world was poor. And you saw like this very small tail out here of some rich people. But for the most part, at the beginning of the Industrial Revolution, everybody was poor. What do we see in 1975? Now we have this kind of two-humped distribution. You have a lot of the world being poor, but then you also have a lot of the world being rich. This is the developed world and the less developed world. What do we see in 2015? We are beginning to see a much more evenly distributed global distribution. But of course, even distribution means that some people have benefited, meaning people down here at the bottom have moved up, but there's a lot of people here that were at the top that have kind of moved down. And once again, that's Americans, right? That a lot of the global poor are catching up with middle-class Americans, or a lot of middle-class Americans are seeing very little changes in their income distribution. And so this looks more like what you would call a good distribution, but that doesn't mean that haven't been winners and losers in it. And a lot of those losers in it have been the American middle class and lower middle class, right? And particularly people who aren't highly educated or don't have jobs that allow them to take advantage of the industries that have thrived in the global economy. So there you have it, right? There in a nutshell is a lot of our dysfunctional politics when it comes to globalization. Okay, our next global fact. I think we've kind of hit on this already, but kind of just make it a little bit clear, is that there are growth miracles and growth disasters, right? In other words, there are countries that have been able to be poor and become rich, and that there's countries that are rich and have become poor, right? Classic example of this would be Japan and Argentina. Japan is the quintessential example of a growth disaster. Japan was one of the poor countries in the world in the early 1800s, and since 1950 has become one of the richer countries in the world. Argentina in the mid 1800s was one of the richer countries in the world, right? In fact, In the mid 1800s, Argentina had a per capita GDP that was very close to what the United States was. What's happened since then? Pretty much no growth, right? The standards of living in Argentina are extremely flat. And so, you know, you can move up and improve and converge, or you can diverge, right? We see both countries doing this. Sometimes we see the same country doing both, right? China is a classic example of that. China is a country that was the richest country in the world in the year 1000. And then for most of the 20th century was kind of a growth disaster in which it fell behind Europe and the rest of the Western world. And then beginning in 1979, it made some fundamental reforms. We might talk about this later. And it began to converge with the rest of the world. And now you can consider it to be a growth miracle. All right, fact number 5. Notice how when we've been talking about growth, we've been talking about country, country, country. Why? Because country and location is still the biggest factor in global inequality, right? Where you are, not who you are, is still the biggest story in global inequality, right? Very little global inequality can be explained by the individual characteristics of people. Most of it can be explained by what country you are and where you live in that country, right? So according to economists, 3/4 of the income inequality we observe across the globe can be explained by which country you live in, and only 1/4 by everything else. So if you tell me which country you live in, I'm going to have a pretty good guess about what your income is. That's going to get me about 3/4 of the way to predict what your income is. So where you are matters much more than who you are, right? To put this in another way, place matters 3 times as much as person. And place not just matters across the globe, it matters within your country too, right? We will talk about this more a little bit later, but there are huge differences in income within the United States between urban and rural areas. Once again, this is a big part of our politics as well, right? Just having gone through a political season, it's hard not to kind of put all this in the context of politics. But we know that there are huge disparities in voting related to whether you're in an urban or rural area, in part because urban areas are doing much better than rural areas economically, right? So yesterday I talked about the citizenship premium. And so let me talk about this again. And so the citizenship premium, the way I like to think about it is think about it relative to a citizen of the Congo, which is the poorest country in the world. If a typical Congolese person would migrate to the United States, they would on average see their income rise by a factor of 92. If they migrated to Sweden, they'd see their income rise by a factor of 71. If they migrated to Brazil, they'd see their income go up by a factor of 13. And if they migrated to Yemen, their income would go up by a factor of 3. What do we draw from this? First off, place, 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 location, location, location. That is the hugest factor in how rich a person is, right? Crazily enough, there's big incentives for somebody in the Congo to migrate to Yemen, right? Tripling your income is no small feat. There's big incentives for this person to migrate to Yemen. So if there's big incentives to migrate to Yemen, how big of an incentive is there to migrate to a place like the United States? Huge, huge. And here you see the root of migration across the world, right? There are huge pressures for migration, in part because there are such big differences in income between where you live or not, right? So yeah, it's not surprising that people risk their life to try to come to the United States, because it honestly, there's huge economic incentives to try to get to the United States and to risk your life, right? There's huge economic incentives to try to get to Europe and risk your life, right? So this happens all the time, and we shouldn't be surprised about it. It's just a simple reflection of the economics, right? That if you can somehow get to the United States, you're going to become a much richer person than if you can't. As I said, place matters within countries too. In the United States, there's big differences in urban and rural incomes. Children born in the poorest 20% of Detroit have half the likelihood of making it into the top 20% as a kid born in the poorest 20% in San Francisco. So even across urban areas, there's big differences, right? Yeah, it's amazing. Just to show you one more graph here, switch over. You know, if I think about, I don't know if you can see this very well. Hold on one second. Somehow I didn't get that graph. Let me pull up an image for you. Okay. So this is one of the more amazing graphs that you'll probably see in this class. Maybe you'll see ever. Certainly explains a ton of our politics, as I said before. This is a graph of the United States broken up on economic activity where 50% of US GDP is produced in the orange areas and 50% is produced in the blue areas. Right? Inequality. We see a small area produces a large percentage of US GDP. And where are these little orange areas? Well, they're major metropolitan areas for the most part, right? And so huge portion of our GDP is produced in urban areas. Why? Well, we'll talk about this as we go along, and a lot, in part because it tends to attract highly educated people with lots of human capital. But yeah, you know, you can see why we have this big dichotomy in our politics between urban and rural areas is because we have such a big dichotomy in our economics between urban and rural areas, right? Okay, finally, switching to our last fact. Growth in the US has been pretty steady, all right? So I said yesterday, one of the things that makes the US one of the richer areas of the world is not always that we've grown the fastest, but we've actually grown the longest and the steadiest, right? So we began growth, you know, relatively early in the 1700s, and we've, for the most part, continued that. In part because other than the Civil War, we've never really fought a major war on US soil. Compared to places like Europe where, you know, in many places, 2 major wars have been fought domestically, which considerably set back growth. But here, what we see in the US is that growth has been relatively steady from year to year to year. How exactly do we calculate growth? Well, let's talk about that here. We got about 10 minutes. We'll talk about that and then I'll let you get going. Okay. 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 So yesterday we talked about a growth rate. And really what a growth rate is it's just the percentage change in GDP. The percentage change in GDP. So you take the new observation, this is YT plus 1, it's a little hard to read, minus YT divided by YT. In other words, the new observation minus the old observation divided by the old observation, multiply that by 100, and that's how you get a growth rate. Or another way that you can express this is you could express it like this, that what is output next period? It's output this period times 1 plus G, where G is the constant growth rate. Okay? So if growth is constant, then you know what growth is next period, or you know what output is next period. If you know what output is this period, you just multiply by 1 plus G. What then would be output 2 periods from now? Well, it would just be 1 plus G times output 1 period from now. But we know what output 1 period from now is. We just calculated that. So if we substitute in here for YT plus 1, we can rewrite it like this. Then, to kind of extend this out, what's YT plus 3 going to be? It's going to be that. Or to make it more general, what's output n periods from now going to be? It's going to be output today times 1 plus G to the n power. What happens if you want to find out what this constant growth rate is? Well, we could rework this, figure out what that is. So put YT here on the other side. Let's take each side to the 1 over n power. I apologize for my writing on this thing. It's a little sketchy. But this is how you can solve for the average growth rate between 2 periods of time. If you're given 2 periods of time, you can calculate what the implied constant growth rate is using this formula. Okay? So let's actually do that for the United States. Sorry, did everybody get that? So let's use this formula and actually do this for the United States. So if we go back to time 0, which is 1870, we saw that US per capita GDP was about 3,200. And what's per capita GDP in 2017? It's about 54,000. So then what is our implied average growth rate? We just used that formula that we had before. GDP at the end of the period divided by GDP at the beginning of the period, all to the 1 over n power. N is the number of periods, right? So there's 147 periods. And then we subtract out 1. Anybody got a calculator there? They want to do this for us? Well, I'll just remove the suspense and tell you what it is. But G bar here is 0.0194 or 1.94%. In other words, a little bit less than 2%, which is what I've been saying, right? A little bit less than 2%. That's where that number comes from. That's where that number comes from. So this is how you calculate the implied constant growth rate, right? The implied constant growth rate. So what does this mean here, really briefly? I know we're at the end of our time here. What does this mean about output? If we graph output in time, what does it look like? Oops. It's an exponential process. With a constant growth rate. So notice that it explodes in levels over time, but the growth rate itself is constant. So why does it explode over time? Because of compounding. Right? That growth begets growth, right? When output goes up, right? If output goes up from 1,000 to 2,000, right? A 50% increase, what happens the next period? If it grows 50% again, it's not just the original 1,000 that grows, it's that new 1,000 that also grows. That's how we get these dramatic increases in levels of output over time. Is because the growth rate is constant, but the level increases at an increasing rate. It's exploding. That's the nature of compounded growth. And so this is where I want to pick up this afternoon. Remember, this afternoon we're going to meet at 1 o'clock, okay? Because I got that faculty meeting. So we're going to meet a little bit later at 1 o'clock. And what we're really going to talk about this afternoon is talk a little bit more about compounding, and we'll talk a little bit more about the mathematics of economic growth, okay? So, all right, any quick questions before I let you go? Okay, if not, I'll see you at 1 o'clock, right? Have a good lunch, everyone.